Exercise 6.3, Chapter 6, Application of Derivatives. Question number 3, find the local maxima and local minima. So, fifth question, that is f of x is equal to x cube minus 6x square plus 9x plus 15. So, we have f of x is equal to x cube minus 6x square plus 9x plus 15. We will be finding f dash of x, that is d by dx of x cube minus 6x square plus 9x plus 15. d by dx of x cube, that is 3x square. d by dx of minus 6x square, that is minus 6 into 2x. d by dx of 9x, that is 9, and d by dx of 15, 0. So, we have 3x square minus 12x plus 9, or we have taken 3 outside, x square minus 4x plus 3, or x square minus 4x plus 3 can be written as x minus 1 into x minus 3. So, we have 3 into x minus 1 into x minus 3. That is f dash of x. When f dash of x equal to 0, 3 into x minus 1 into x minus 3 equal to 0. From this, we can write x equal to 1 or x equal to 3. We have two values for x. Now, what is f double dash of x? That is d by dx of 3x square minus 4x minus 3. Or at 3 into d by dx of x square, that is 2x. d by dx of minus 4x, that is minus 4. d by dx of 3 is 0. So, we have f double dash of x is equal to 6x minus 12. At x equal to 1, we have f double dash of 1, that is 6 into instead of x 1, that is 6 into 1 minus 12, that is minus 6. So, we have minus 6 as f double dash of 1, that is less than 0. So, it is a local maxima. So, what is local maximum value? That is f of x is equal to f of 1. We are applying it in the equation f of x, that is x cube minus 6x square plus 9x plus 15. So, 1 cube minus 6 into 1 square plus 9 into 1 plus 15. By solving, it will be 19. So, we have the local minimum value, that is 19. Now, at x equal to 3. So, we have f double dash of 3, that is 6x minus 12, that is 6 into 3 minus 12, that is 18 minus 12, that is 6. 6 is greater than 0, that is a positive quantity. So, we have a local minima here. What is local minima value? That is f of x is equal to f of 3, that is x cube minus 6x square plus 9x plus 15, that is 3 cube minus 6 into 3 square plus 9 into 3 plus 15. So, that is the answer is 15. So, local minima value here is 15. Moving into the next question, we have the sixth question, that is g of x is equal to x by 2 plus 2 by x, where x is greater than 0. So, we have g dash of x, that is d by dx of x by 2 plus 2 by x. What is d by dx of x by 2? That is 1 by 2. d by dx of 2 by x, that is 2 minus 2 by x square. So, we have g dash of x is equal to 1 by 2 minus 2 by x square. What is, when g dash of x is equal to 0, 1 by 2 minus 2 by x square is equal to 0, or x square minus 4 equal to 0, or x, we have two values, that is plus 2 or minus 2. So, what is g double dash of x? That is d by dx of 1 by 2 minus 2 by x square, or d by dx of 1 by 2, that is 0, d by dx of minus 2 by x square, that is minus 4 by x cube. So, minus into minus plus, so plus 4 by x cube. So, d double dash of x is equal to plus 4 by x cube. At x equal to plus 2, we have g double dash of x, that is 4 by x cube, that is 2 cube, that is 4 by 8, that is 1 by 2. So, it is greater than 0. So, g double dash of x, when it is greater than 0, we have the local minima here. So, what is the local minimum value? That is g of x is equal to x by 2 plus 2 by x, applying in that equation. So, g of 2, that is 2 by 2 plus 2 by 2, that is 2. So, we have the local minima value is equal to 2. So, now, at x equal to minus 2, we have g double dash of minus 2, that is 4 by x cube, right? 4 by minus 2 whole cube, that is minus 1 by 2, which is less than 0. But in the question, we have said that x should be greater than 0. So, there is no possible value here. Next, seventh question, that is g of x is equal to 1 by x square plus 2. So, we have given g of x is equal to 1 by x square plus 2. Then, what is g dash of x? That is d by dx of 1 by x square plus 2. 1 by x square plus 2 can be written as x square plus 2 whole raised to minus 1. So, d by dx of x square plus 2 whole raised to minus 1, that is minus 1 into x square plus 2 whole raised to minus 2 into d by dx of x square, that is into 2x. So, we have g dash of x is equal to minus 2x by x square plus 2 whole square. When g dash of x is equal to 0, we have minus 2x into x square plus 2 whole square is equal to 0, or minus 2x is equal to 0, or x is equal to 0. Now we are not moving into g double dash of x because we will be finding it from the g dash of x. We will be finding local maxima, local minima value here. So let us consider the case of g dash of x when x is less than 0 and when x is greater than 0. So slightly less than 0 or slightly greater than 0. When in the case of x. So what happens when x is less than 0? That is g dash of x, applying it in the equation of g dash of x, that is will be a positive quantity. Similarly, when x is greater than 0, g dash of x will be a negative quantity. So now when we draw a graph with these quantities, we will be having a graph from positive into the negative. So from this we can conclude that we have the local maxima at x equal to 0. So at x equal to 0, we will be having the local maxima and the local max. What is local maximum value here? That is g of x, that is g of 0, that is 1 by x square plus 2. That means 1 by 0 square plus 2, that is 1 by 2. So at 1 by 2, we have the local maximum value here and there is no local minimum. Now 8th question, we have g of x is equal to x root 1 minus x where x is less than 1. So we have f of x is equal to x root 1 minus x where x is less than 1. So what is f dash of x? That is d by dx of x root 1 minus x. So we are applying the product rule here, that is x into d by dx of root 1 minus x plus 1 root 1 minus x into d by dx of x, or x into d by dx of root 1 minus x, that is 1 by 2 root 1 minus x into d by dx of minus x, that is minus 1, plus root 1 minus x into d by dx of x, that is 1. Or we can write minus x by 2 root 1 minus x plus root 1 minus x, or by cross multiplying we have minus x plus root 1 minus x into 2 root 1 minus x. Root cancel, we have 2 into 1 minus x divided by 2 root 1 minus x at the denominator. Or we can write by solving the bracket, we have minus x plus 2 minus 2x by root 2 root 1 minus x, or minus x minus 2x, that is 2 minus 3x divided by 2 root 1 minus x. So we have got what is f dash of x. So that is 2 minus 3x divided by 2 root 1 minus x. Now we will be considering when f dash of x is equal to 0, that means 2 minus 3x by 2 root 1 minus x is equal to 0, or from this 2 minus 3x is equal to 0. So the value of x will be 2 by 3. By solving, we will be having x equal to 2 by 3. So from this we can write same as the above question, we will be considering f dash of x here. Here the x should be less than 2 by 3 and greater than 2 by 3. So when in the case when x is less than 2 by 3, we have f dash of x, applying in the equation 2 minus 3x divided by 2 root 1 minus x. We will be having f dash of x a positive quantity. Similarly, when x is greater than 2 by 3, we are applying in the same equation f dash of x, we will be having the quantity as a negative one. So we can say that when x is less than 2 by 3, we have f dash of x is positive, and when x is greater than 2 by 3, f dash of x is negative. So by drawing a graph, we can see the graph is from positive into the negative. So what is the local maxima here? That is 2 by 3. At x equal to 2 by 3, we have the local maxima. What is the local maximum value? That is f of x, that is what is the f of x, that is x root 1 minus x. So we are applying instead of x 2 by 3, that is 2 by 3 root 1 minus 2 by 3. By solving, we have 2 by 3 into root 1 by 3, or 2 root 3 by 9. So at 2 root 3 by 9, we have the local maximum value.